Welcome. I want to continue talking about the language of proofs with conjunction, which is what we mean when by like and is called conjunction. So let me just get started so that hopefully this becomes clear pretty quickly. So how we write this is we have P, and then you can remember this is and because it looks like an A without the line across, and then Q. When we write this, what we mean is it means P and Q. So we have P, and then here's another one of these words being a logic word, Q, and then we write Q. So this is P and Q. And this is called conjunction. So it's called conjunction is the logic-y formal term for it. And this is also kind of best described by one of these truth tables. So let's just kind of go ahead with that. So also best described by a truth table. And it's going to look a little bit different this time. So we have, but let's start with, it's going to start the same where we have P and we have Q, and then we need to worry about, and then we have P and Q, and we're wondering when each of them is true or false, what that says about P and Q. So then we're going to want to look at this. Okay, and here we worry about, so we have P is true, true, false, false, and Q is true, false is how we make sure that we get all the combinations of true and false between them. So if both of them are true, then P and Q is also going to be true. Right. Then P and Q is also true. If P is true, but F is false, then it's not true that both of them are true. So altogether, it's going to be false. And similar here. And if both of them are false, this is false. Okay? So what we kind of have going on here, right, is that this one says that if P and Q are both true, so if P and, suggestively, Q are both true, then this P and Q is also going to be true. And then what all of these are telling me is that if either P or Q is false, so if, and then this is an either, we only need one of them to be false. So if either P or Q is false, is false, then this the and statement, the conjunction, is also false. Okay, so to summarize, what do we have going on? We have that P and Q is true precisely when. So we have P and Q is true precisely if both P and Q is true. Or P and Q are true. Sorry. Okay, so it's a little bit different than when we were talking about the disjunction. And then let's kind of look at this, what this tells us about proving things. So to prove, or to show that P and Q is true, then we need to show right? We need to show that P is true and Q is true. So P is true, then we need to show that P is true, and we need to show that Q is true. So, and show that Q is true. Okay? But if we want to prove them false, so to prove a statement of this form is false, then we're going to need to show we need to either right, show that P is false. All right, so show that P is false. And we'll go ahead and write this in, no, we won't go ahead and write that in. It'll look like this. Or, right now this is an or that Q is false. Okay. And once again, the second part is actually coming from De Morgan's, one of De Morgan's laws. So looking here, right, so this follows from another of De Morgan's laws. So follows from another of De Morgan's laws. Right, so this one is going to be that if we have not P and not Q, so so how do we, yeah, okay. Right, if we want to take not of P and Q, right, if we want to negate this statement, right, this is the same thing, so this is equivalent to right, having this is equivalent to not P, and then just like in the other one, we need to flip this, so not P or not Q, right? So you're either, you know, having that this is false is the same thing as having that this is false or this is false. Okay, so that's what's going on with that. And then there's these logic laws, De Morgan's laws, that actually tell us that this is how these work. So this is conjunction. This is the and. This is another one of these symbols, these logic words that you need to use like a logic word. And the way that it works is in order to show that it's true, you need that both P and Q is true, because that's precisely when it's true. Which means that it's false when either P is true or, sorry, when either P is false or Q is false, okay? So that's how you work with and statements in kind of a logical manner. Okay, so I hope that was helpful and made some sense, and I will see you in the next lecture.